Okay, in this video I'm going to work out an individual integral. It is going to be the integral of tangent x squared dx. Alright, and it's going to involve a lot of Pythagorean identities and then one particular spot where either you have it memorized or then you just kind of pull out a little trick to be able to integrate the rest of the problem. So for starters here, this is the tangent x quantity squared. Okay, I've got a squared quantity here, so I'm going to switch my tangent to sine over cosine. That's a common trig substitution there. So it's going to be sine squared x over cosine squared x dx. Alright, and then at that point I'm going to refer back to my Pythagorean identities. Okay, so Pythagorean identities, we'll write them out here just in case you have forgotten them. Alright, there is one that says sine squared x plus cosine squared x equals 1. If I want to solve this for sine squared x, since I have a sine squared x in the numerator, alright, sine squared x is going to be equal to 1 minus the cosine squared x. Okay, so I'm taking a Pythagorean identity and solving it for something that I need. Now, that's going to allow me to take this 1 minus the cosine squared x and replace that numerator. So then I'm going to have the integral of 1 minus cosine squared x all over cosine squared x dx. Alright, now at this point, if I've got a rational function, which I do, and there is either adding or subtraction going on in that numerator, I can very easily break this up into two individual integrals. So then I can have the integral of 1 over cosine squared x dx minus the integral of cosine squared x over cosine squared x dx. Alright, and what you need to do is to check this is if I can subtract these two fractions and get this fraction, then I know it's equivalent. And so as long as I do that subtraction and it works, then I'm good. Since I've got common denominators there, it makes it very easy to check to make sure that that works. Alright, now this right here, cosine squared x over cosine squared x is going to be 1, so that's going to make this integration really nice. So then I'm going to have 1 over cosine squared x dx minus the integral of 1 dx. Alright, now at this point, this right here, some of you may have this memorized. If you do not have this memorized, then you're going to need to work this integral out, and you're probably going to use a u substitution. But the thing is, you've got to know what to pick for the u so that you can get this cosine squared x to fall out. So I am going to actually take the time, assuming you do not have this integral memorized, I am going to do this integral over here with a u substitution. Alright, now the trick here is going to be to let our u be tangent. And then you're thinking, well, where the heck did that come from? Okay, well, because tangent is sine over cosine. Okay, and then I'm going to have a quotient. When I do that quotient rule, that denominator then is going to be a cosine squared x, which is what I need there. So I'm going to let u be tangent, alright, and then I'm going to simplify that even more to make it sine x over cosine x. Alright, because if this is my u, I'm going to have to do the derivative there, which will give me a cosine squared x on that bottom. Okay, so I'm going to take the derivative of both sides. Du is equal to, and then let's just go ahead and crank that out because that might take a little doing for some people. So cosine x times cosine x minus sine x times a negative sine x, and then all over a cosine squared x. Alright, so then simplifying here a little bit, du, that's going to give me 2 cosines, so cosine squared x minus, plus, because that's minus a negative, so this will be plus sine squared x all over cosine squared x. Alright, now this we've already dealt with up here. Sine squared plus cosine squared equals 1, so I can replace that with a 1. Let's go ahead and put that dx on there. So du is going to be equal to 1 over cosine squared x dx, and then multiplying both sides by that cosine squared x is going to give me a cosine squared x du is equal to dx, which is what I wanted there, so that when I go to do my substituting there, then things are going to cross out pretty nicely. Alright, so coming up here, then I'm going to have the integral of 1 over, all right, now cosine x squared is going to stay because I didn't do a substitution there. I'm going to replace that dx with cosine squared x du, and then minus the integral of 1 dx is just going to stay. All right, that's going to allow me to cross out those cosine squared of x. So then I'm going to have the integral of 1 du minus the integral of 1 dx. Okay, so from here, integrating 1 with a du is going to make that pretty simple. It's going to be a u, then the minus. Integrating a 1 with a dx is going to give me an x. All right, I made a u substitution here. Initially, I let u be tangent x, and then I switched it to the sine over cosine just so that I could work the derivative out a little bit easier there. So I'm going to replace this with tangent. So this will be tangent x minus x, and I have integrated at this point, so I'm going to put that plus c in because I haven't done it yet. Okay, so final answer there. All right, now some people, depending on how long you've been doing integrals and stuff, might have the fact that this integral of 1 over cosine squared x dx, some of you might have that memorized and automatically know that's going to be tangent x there. Okay, so if not, that might be a good one to memorize, but if not, as long as you remember that a u substitution is going to work there and just about how you have to twist that one around to get it to work out by doing it longhand, that's a nice little way to do that. So definitely thanks for watching, and if the channel's helping you and the videos are helping you, then please share with your friends and don't forget to subscribe. Thanks.